We're going to take a look at a little bit more quadratic graphs. So for quadratic graphs, what we're looking at today are quadratic graphs with word kind of problems. So the first one, or what we're going to look at, is this example here. And this is example 5 from page 395. So this question here, it says the height h in meters of a model rocket in flight can be approximated by h equals minus 5 t squared plus 24t plus 1, 0 less than or equal to t less than or equal to 4, where t is time in seconds. By copying and completing the table below, plot the graph of h. So we're all okay on doing that part. We should be all okay on doing that part at this stage. You're substituting this into your calculator. You're going at the start from 0, at the end to 4. You're going up in ones because it's going 0, 1, 2, 3, 4. It's going up in 1 each time. If that was going up in half, so you'd go up in half. And when you substitute that in, you're getting 1, 20, 29, 28, and 17. Okay? So when I graph that, I end up with the graph that I have over here. That's the graph that I get. We'll make that a little bit bigger so that we can see it. So for this graph then, what we're looking to do is to answer these questions. So the B questions here. Now these questions, what they're going to ask is they're going to ask you what is the height at this time, what is the time at this height, so on and so forth. So what you're looking to do is to use the graph and to work out, are they giving you a value from the x-axis, or are they giving you a value from the y-axis? And then if they're giving you an x-axis value, that means they want a y-axis value for an answer, and opposite, and so on and so forth. So using your graph, part 1 here, it says the height of the rocket after 3.5 seconds correct to the nearest meter. So they're looking for a height, so they're looking for something along the y-axis, and they're looking for it when the time is 3.5 seconds. So I'm going to go to my time and I'm going to go to 3.5 seconds. And as you can see, I've drawn a dotted line up and a dotted line across. And I can see here that I'm coming out with around 23. So if I put in B part 1, I'm getting... So if I put in B part 1, I am getting 23.5 meters. Okay, so for the next question then, B part 2. So for B part 2, they're asking me when the rocket's at 18 meters, use your graph to find when the rocket is at 18 meters, correct to one decimal place. So you're looking for, they're giving us 18 meters, so they're giving me one of the heights. So I must be looking for one of the times. So I go to my 18 meters, I go across, and then you can see my dotted line again, and I end up around this point here. And that point, and these are all estimations, they're not all, they don't have to be as accurate. If the answer is slightly different in the back of the book, when you're doing these kind of questions, that's okay. They take it from your graph in a leave insert question. So in and around 0.8 seconds. Okay, and part 3 then. So for part 3, they're looking to find the maximum height of the rocket. So if I'm looking for the maximum height, I'm looking for the highest point. Now for this graph, if I had drawn this and I'd gotten to here and I tried to go straight back down, I wouldn't have made it to my point. So that's why I figured it must have peaked slightly after that value there. So if it's peaked slightly after, I've just kind of made a loop in and around here. It's a gradual loop, and it means that I need to get from this point to this point. So again, if it's slightly different than what the answer that you'll be getting, that's absolutely fine. For here, because I know that this pink point here is 29, the other one's going to be slightly higher. I'm going to guess around 29.5 meters. And again, that's an estimation. So it's looking for the maximum height. That's 29.5 meters. If they're asking the maximum point, I would have to then go down here, and it's around 2.3, 4, or maybe 2.45, something along the lines of that. Okay, and that's how we answer those questions there. Now what they could possibly do is they can ask you to verify things algebraically. So for instance, if I was asked to find this one and prove it algebraically, what I can do here is they're giving me a time. I can sub it in for my time into my graph, and I should be getting out something along the lines of that. Again, your graph, the figures you're taking for your graph can be slightly wrong. because it's just from your what you're looking at. Okay, for this one here, when the rocket is at 18 meters, correct to 1 decimal place. So that one there, you could have also gone across. I'm just looking at that now and realized. And you could have also had about 3.9 as well. So, or 3.9 seconds, sorry. Okay, for that one you can sub in your 80 meters into your h value and then solve, and you'll get 2 values for t if you're doing that algebraically. The third one then, the maximum height of the rocket. So if you're asked for the maximum height, to find the maximum height, that's when we go about completing the square. So for this here, you would complete the square using that. And what you do is you take out -5 as common, you'd be left with t squared minus, and then whatever 24 over 5 is, and so on and so forth. And you would solve and complete the square, remembering that anything that you complete the square is in this form here, where your maximum point is minus b and c. So you take this, you change the sign, and you take this one. So that's your maximum point if you were completing the square.